Let's check this integral out. On this one, I wanted to throw in some variety into this particular series of videos. And I meant to put an extra x in here and forgot it. So this thing ends up simpler than I wanted it to be, but we'll just do it regardless. So the informal solution for this, I see a square root of some function. If I can find the derivative of that function sitting inside the integrand, then I'm prepared to guess the chain rule backwards. So the derivative of that function, 2x minus 3, is just 2. This is all a u-substitution does. It's just you usually don't have to be so formal about it. So I'm going to show you how people really do this integral, like how physicists would use calculus if they had to do this. So now that I have the derivative inside there, I have a 2x plus 3 to the 1/2 power sitting right next to the derivative of 2x plus 3. So I can just guess the antiderivative. Here, let me slow down a bit. I don't want to lose you on this. I'm viewing that as an exponent. All right, so I guess the antiderivative just by using the power rule. So I add 1 to the exponent and divide by the result. So that would give me a 3/2, and then I divide by 3/2, which is the same as multiplying by 2/3. And I'm just going to pause right here to check that it worked. If I differentiate this, the 3/2 and the 2/3 kill each other. I subtract 1 from the exponent, and I end up with a 1/2 there. And then the chain rule says you've got to multiply by the derivative of 2x plus 3, so that produces this 2. So it worked. Any method you can come up with to find an antiderivative, if you can prove that it worked by differentiating, then that's good enough. So I have 1/3 quantity 2x plus 3 to the 3/2 plus c.